Hello, welcome to everyone. In this video, this is lecture number 6 on the nanomaterials and application. Today we want to discuss about the applications of the nanomaterial. In this part we will be covered the application of the nanoparticle, quantum dot, nanowire and thin films for photovoltaic device like LED, light emitting diode, solar cell, then single electron transfer device, then CNT, carbon nanotube based transistors, then nanomaterial device, that is quantum dot, heterostructure laser, then optical switching and optical data storage, then magnetic quantum well, then magnetic dot, magnetic data storage, then micro electromechanical system MEMS and nano electromechanical system NEMS. So all will be covered in this section. You can see this is the syllabus of this semester 6 nano materials and application. In first lecture we covered the nanoscale system. In second lecture we cover synthesis of nanostructure materials, and then third chapter we characterize the nanostructure material. In fourth chapter optical properties, and fifth chapter electron transport. Up to this portion we covered in the last fifth lecture. In the sixth lecture we want to cover the application of the nanomaterial. So if you want to watch the previous lecture, you can go through the description box, link are given there. So let's start. First, nanoparticle. Nanoparticle, you know the particle size of the nanometer order, and its properties differ from its bulk material. So that's the nanoparticle. Its use in various fields, suppose such as in medicine field. Medicine field, the nanoparticle use is various various point. You can see nanoparticle can better deliver drug to a tiny area within the body. That is, if you use in a bulk material, it's act on the whole body, but if you use the nanoparticle, it's act in the particular position at the particular point where it's required. And particle size and surface characterization of nanoparticle easily manipulated as you require. You can control the size of the nanoparticle easily, and you control the location of action. You can also control the location and the targeted nanodrug. So a nanoparticle used in medicine is the very useful things. And the environmental issues is another important part, such as the photocatalytic copper tungsten oxide nanoparticle break oil into the biodegradation, and the gold nanoparticle used in porous manganese oxide break down the volatile organic pollutant in the air. So for air pollution you can use the gold nanoparticle. Iron nanoparticle is mostly used in the water pollution, that is its carbon tetrachloride pollution is clean up, and also arsenic also clean up from the iron nanoparticle. So you can see environmental purpose the nanoparticle used widely. Another part is the energy and electronics. For energy, that is the solar cell is the used nanoparticle widely. Silver nanoparticle used in the ink for the conducting line in the circuit board. You use the silver nanoparticle in the conducting line in the circuit board for the tiny energy conservation, that is the electronics. Silicon nanoparticle used in the lithium ion battery, which increase the battery power and reduce the charging time. Nanoparticle in solar cell is widely used. Another in the manufacturing and the material, that is the silicon carbonate nanoparticle, which is produce strong lightweight material, that is its weight is light but it is strong. Silicate nanoparticle, you can see in your the package which are ordered from Flipkart, Amazon. You can see sometimes the material packaging with a tiny packet which is silicon nanoparticle, which actually barrier to the moisture to the gas. So it reduce the spoiling and drying out the food. So it's very useful, silicon nanoparticle. Then zinc oxide nanoparticle, it's protect wood, plastics, textile from the ultraviolet ray. Silicon oxide nanoparticle fill up between the carbon fiber. Silver nanoparticle kills bacteria, clothing, odor resistance. So these are various fields where use the nanoparticle. Next is quantum dot application. The size of quantum dot is about 10 nanometer. Band gap of quantum dot is larger than that of bulk one. So its use in LED solar cell with different light, and its size control change the color of the light also. Graphene quantum dot doped within the nitrogen can use as the catalyst to make the hydrocarbon from the carbon dioxide. And the magnetic quantum dot in the spinotonic semiconductor device used in memory chip, graphene quantum dot used in immunity and pressure sensor, quantum dot used in produce image of cancer tumor and use cancer therapy also. Quantum dot miniature the laser the communication system which gives you high speed low power consumption, and in TV computer also quantum dot are used, and in solar cell quantum dot used widely. Nanowire, you can see the nanowire is like that. Its surface to volume ratio is very high, which helps to the absorption of the huge light and produce the electron hole pair, which enhance the efficiency of solar cell. So silicon nanowire is widely used in the solar cell, and this solar cell also known as the black silicon because it's absorb all kinds of light like a black body. That's why it's called black silicon also. Nano are used in the transistor also, and higher conductivity due to unidirectional structure. It's make AND gate, OR gate, NOT gate, FET, etc. and produce black silicon, you know. Yeah. And black silicon also used for cooking because solar oven, you know, for solar oven, if you use black silicon, it's absorb much higher number of solar light and cook the food. Next is the thin film application. There are various use, but mostly used in LED light emitting diode and solar cell. You know, this is a LED. There is a PN junction. The N layer is thin and P layer is thick, and there is a forward bias. Due to forward bias, the electron from inside jump to the P side, and there is huge hole, so they recombine, and due to recombination the electron jump from higher energy state to lower energy state and radiated energy, which energy in the form of light. That's why this is LED. Here the thickness of inside is very low, such that the light emitted from this depletion region, that is the junction, can easily transmitted from the surface. So this thin layer used for the LED light emitting diode, and the band gap tuned for the different color of this material of the light. You can use red, green, yellow, etc., etc. Color can be changed by the changing the material band gap. And the in the solar cell application, you can see there is P side, this is N side, and in between there is depletion region. When the when the light incident on this suppose this light incident, there is light incident on the tissue material, that is the transparent conducting oxide material. Light incident, we use this material because it's transferred the light but conduct the material. So light transparent to this tissue, then end it reaches at the junction. At the junction it generates electron hole pair, and they are collected by this tissue here, and this is aluminum, and they flow in the outer circuit, and this gives you the power. So from light it can generate electricity. So light energy converted in electricity in the solar cell. In opposite LED, electricity converted into light. This is the light are emitted here, the light used to get electric. Okay, so these are the use in thin film. Next is single electron transfer device. Single electron transfer device means the device which transfer a single electron by tunneling effect. You can see this is the structure, that is the gate source drain quantum dot here, and there is gate capacity, and into the gate capacity the electron transfer from quantum dot to gate by a single electron by the tunneling effect. Okay, to operating principle is Coulomb bracket effect. You know, in the Coulomb bracket effect is like that the electron cannot transfer even through the tunneling, is the Coulomb bracket. Just above the Coulomb bracket effect, the electron transferred to the quantum dot is single electron, so you can precisely control the current within the circuit. So this is very useful thing. You can see the application in ACD is the super sensitive electrometer for single electron transmission you can sense. So this is super sensitive electrometer. Electrometer is such that where you can easily find out the there is any conduction within the material, there is any electric flow within the material, is the super sensitive electrometer. single electron spectroscopy, DC current standard, temperature standard, voltage localized, and charge sensor. All are used in the single electron device. Advantage of AC is low energy consumption, high sensitivity, compact size, high operating speed, simplified circuit, reproducible. But disadvantage is difficult to fabricate large quantity of ACD by traditional optical lithography, difficult to link ACD to outside environment, and practically difficult to fabricate ACD. So these are the advantage and these are the disadvantage of single electron transistor or single electron device. Now CNT, carbon nanotube based transistor, 1991 carbon nanotube was synthesized under this behaves as strength because its cylindrical configuration strength is the structure. Their properties like that is high thermal conductivity, high electrical conductivity, high aspect ratio. Aspect ratio means surface to volume ratio is 10 to the power 8 is to 1. That is the surface area much higher than its volume. This is helps in reference purpose. And high elasticity, high tensile strength, highly flexible, low thermal expansion coefficient. So these properties of CNT use in the various application like field emission due to high electrical conductivity, energy storage, high specific surface area, conduction property, conductive adhesive, thermal conductive material, molecular electronic, structural application, biomedical, air and water filtration, and catalytic support. So these are the application of the CNT. Next is the nanomaterial devices, that is quantum dot heterostructure laser. You know, in this laser there is core and cladding where these optical lights are actually processed, and its heterostructure, that is the band gap of defined material as defined, and quantum dot which use this heterostructure, and varying the band gap change the color of the laser. Advantage is precise tuning of wavelength by changing the quantum dot size and operate over broad spectrum of wavelength, and can switch on off instantly due to low threshold current and ultra high temperature stability. Disadvantage is difficult to produce high quality and precise size quantum dot, and heterostructure quantum dot manufacturing is also difficult. Application used in CD, DVD, laser printers, used in high density and optical information storage device. Next one is the optical switching and optical data storage. Optical switching, you can see there is a core and cladding, and you can see there is different lines, and there is all of the transmitted here. Which lines are which operates like a switch. It's operates like a switch. Inside the optical fiber cable, signal separate using defined wavelength. This technology is known as wavelength division multiplexing. Okay. Advantage: high transmission speed, emission optoelectronic from electron, low cost, environmental friendly, low power consumption, increased stability of the optical communication. Disadvantage is the error rate monitor is difficult, analog signal are amplified, not generated, high cost of optical switching. Use multiple network with optical crosses and like that. Optical data storage, you can see in a CD there is dot like that. Actually in 3 dimension there will be nanostructure, there is peak and there is value. When the lights laser light incident, when there is the peak, this is reflected and detected by detector, and when is valley it's absorbed, no, there is 0. So when this from upper side peak side, this is 1 and this is 0, so there is a lots of binary number 1 and 0, and this gives you the information. This disk is rotate and gives you the information of this data. Magnetic quantum well is like that, and the different materials, silicon material used to such get the such magnetic well, and you can see this type of aluminum, gallium arsenide and gallium arsenide, gallium arsenide, this band gap is low, this is high. Due to this formation you will be get this type of well. It is used in diodes laser, DVD and laser printer, IR laser and laser. Since the width of the quantum is comparable with the de Broglie wavelength, quantization will be result and the quantum well potential energy are lowest. And since the thickness is 100 nanometers small, even the current will be population inversion and lasing action will be operating here. Magnetic quantum dot is the very small magnetic semiconductor particle. They tightly confine electron and hole. Magnetic quantum is signal objective with the bound or discrete state as in the case of atom. Magnetic quantum dot is the artificial atom. Property is intermediate between the bulk semiconductor and discrete molecule. Magnetic data storage is like that. There is a point is like a magnetic state. There are two types of magnetic material used for 1 and 0 binary disks, and used in the hard disk, floppy disk, magnetic tape, magnetic strip, like that. And information in written and read from the storage medium and move the read and write of this thickness. There are two example you can read down, and example very easy. Then micro electrochemical system is like that, is a miniature machine of both mechanical and electrical component. Dimension is 20 micrometer to 1 nanometer. Is process used to catalytic IC. Application is inject printers, aerometers, modern cars, magnetic sensor, navigation system, protocol device, precursor system, medicine. Any MS is the nano electromechanical system. In case of the application is written here, you can see, and this is the advantage of NEMS. Negative impact of this and this is the difference between NEMS and MENS. This is critical structure below 100 nanometer. This is 20 to 1, small compared to MENS. This is higher. Surface to volume ratio is high. This is low. More efficient, high frequency. Like that. Application of NEMS written here, and this is the MEMS. So I think you can take this screenshot and write down this note. Okay, so these are the question you must solve with the person. This is all about me. This is my contact detail, and this is my YouTube channel details. Go to the channel, we get different free related videos, some mathematics. Like this session if you learn something from this session. Share this video to your friends so that he or she also get benefit from the video. Subscribe the channel if you new in this channel. Those already subscribed, thanks for subscribing. Hit the bell icon to get notification of you. So take care. We'll meet in the next video as soon as possible.